fine.
I was trying to do it from here, full screen.
Here is full screen, but not there.
Ah, but not there. Okay, that's fine. Okay.
I think that's really fine. Doesn't matter. I think that's fine. Okay, just go quick. Yeah, introduce this work is my student's work. The first author, we call it Pei Hao. Unfortunately, we have US. Well, yeah, a little bit introduce this FIU. FIU, maybe you are in UK. Well, this one we call it Florida International University. We are exactly in the Miami. We are the largest public university in Miami. We have more than 50,000 students. Yeah, a pretty large university. We are serving. Yeah, you know, Miami not only the beach, not only the cruise, but we also have a pretty much large university. Yeah. So this work, yeah, we call. I think is I think multi-MAE. I think MAE. If you are working on the vision area, I'm not particularly very working on this area. I'm basically a signal processing and robotic guy, so that's a little bit different. So, but this one, we have a pretty large project, so this one is part of this project. One relation to the, you can see the emotion. So that's one. So we want to enhance our especially dynamic emotion recognition. So why are we dynamics? As previously, we have a lot of emotion work to have been done. So majorly, we have a single mode. We do using the facial. We also using the tone, or more general, we have sentiment analysis from the internet, from your rating. So that's all things. We do it a lot. So that's the old style. Now we do multimodality. So we combine with basically we have the combined with the facial, combined with the tone, and also the text or context, the language. So that one is now we have so a lot of emotion is more complicated. So we use multimodality to try to understanding it. Especially we are currently working with a lot of video data. So we can take the video, very cheap device. We can take the video, although sometimes the quality is not that good. But if we have some of our model can do it, it's likely so better to combine with all these three. So that's would be the perfect things, or definitely be better than the single modality. So that's why. But today we are this current is what we're still working on. So we are this one. Today we are more working on the fusion of the audio and the video. So we are not necessarily to do on the context because you might project the contextual information is another area we have special coding, so like the label we have, but then not necessarily to be here. So we are we are more want to do combine with the facial and the tones. So this one we are working on this the purpose to explore the impact of dynamic feature correlation in the multimodality data on the emotion recognition, especially call it the dynamic emotion recognition. This should be go next. How about this one? Oh, a little bit back. This one. So that's one we have this challenges that we listing here. Consider that's the model for extracting dynamically correlated feature. So we want to get some correlated from the audio, not only the spatial, but also the temporal correlations. So that's one is the things not limited on the single modality. So we want to get the dynamically correlated feature. Usually we need a lot of amount of training data. So the state-of-the-art dynamic emotion model that's interpretation on the supervised learning. That's because we have the label from the label training to make not that quite robust. So that's one of the things. Yeah, they have enormous data. So the audio, video data you get YouTube, you have huge data. You can train, not using your own data, you're just using the old natural data. So you are balanced, you have all the natural data on the YouTube. So why you don't use that one? So that's one of the things, so it give you a more interconnection there. So that's one is not my work, it's the MAE's work. I think if you are working on that area, it's MAE's work. So that's one, yeah, if you have something, I'm not particularly introduced to MAE, it's not my work. Then the future power dynamic, the emotion recognition model only consider the correlation between the feature sequence of single modality. That's one we want to get even further, to get the more, not only spatially or temporally, we want to get the spatial temporary fusion. And how to do the better fusion? That's the work we investigate in this project, this project. Yeah, so that's one is the general things. Yeah, this is a little bit review of the previous work with the single demand, the dynamic work. So you're using the single, if you're using the facial, that's one, I think if you're working on this area, you know that database. Have a lot of database working using that one. So they create the visual also, necessarily, they also have the audio data. Audio data, we don't use actually using the time sequence. There's a lot of previous work as a signal processing guy. I'm working on a lot of you say MFCC. We say the spectrum. Our speech, we have a special spectrum. If you want to characterize who is speaking, or you have the emotion there, you can see from the spectrum or frequency distribution from this spectrum, you can get those information. So those one is the previous work. We have the single modality. Now we want to do is, yeah, here. So you can see on the later part. So this the bottom figure, we contrast to the previous the single modality data. We want to combine with the time sequence of the phase, the facial time sequence of we call time sequence of the spectrum. You know, the spectrum is usually we have spectrum is the x-axis standing for the time, y-axis standing for the frequency, and the plot color shows the intensity. So, however, we using the sliding window, although the window is the overlap. So, but we still sliding the spectrum over the time. So then we can corresponding to the single image data. So that's one is the thing we can synchronize the imaging and the spectrum data together. Although spectrum we use in the center, you can use the time as the center, you can spectrum to elongate to the spectrum data. So that's one is the C. We do the investigation of spatial temporal in the correlations. Is that one? Yeah. So that's one is the contribution. We have a new framework for the dynamic emotion recognition that extends the conventional approach using single modality into the multimodality input and passing the both video and audio elements. And also, as you said, we say we want to optimize how we can do the audio and video more efficient. That's the second contribution. So this one, you can see I already explained how we can do the time logging. So basically, the data set is all from the available on the internet. You can download this, share that one. Is the video data is usually 3 seconds video data. They have the facial, the audio data, actually the video data. And now we can see we have the corresponding. We can have the three. We can downsample the where you here can average downsampling the video data to the 16 frames into the 3 seconds across 3 seconds, and also the audio data. So we also moving our spectrum data. So then we can also create the likely the FCC as the 16 MFCC. So that's what FCC, we say the male frequency spectrum. So that's why I think if you are using this area, you should definitely know that. That's pretty standard. And the fusion. Now we do the fusion. So we have investigate or compare with the 6-channel fusion. This one, yeah, we say concatenate. So we can directly put the E16 frame the data, the facial data and the spectral data directly. You just concatenate and combine it, and then we can say create 16, yeah, concatenate the new frames. So then we can put the large language, we don't say large language model, large MM model, the large multimodal models, MAE model. So this is the first one. Next one, we do the, oh, yeah, that's one we can overlap together. We can just combine them, adding the summation together. So you can see that you can see the facial part, you can put some really purple, the high density. So we can add them together. Then how about that? That can, how about that integration? Next one, yeah. So we can in sequence. So facial first, then we do the audio spectrum later. Then we can yeah, this combined inverse. Then one by one sequence, we do it like this way. And finally, random. Finally, we random put the sequence in the six frame data. So we are testing this for random sequences. Now, what happens? Okay, I don't need to worry much about this one. It's just pretty we're using the transformer. So basically, it's the MAE model. We use this one. We also the transformer model. So you can see the multimodal. We have this added another layer, another connection tag. So that's one is the pretty standard. So now we can see the result. Yeah, this one is how the data formalized. Yeah, we test the 3 general available data set. So yeah, basically you can see. So we compare with our different audio video integration method. So we can see this one like this way. So you can see the bottom part. We can have this one is a VNA, and we also test the single using the video or using the audio using the MAE. The MAE actually you can simply say it's the large video model self-trained on the they have how many? Around this number, a pretty large model. It's 6 billion parameters, if I'm not remember 60 billion, something like that one. Yeah, but it's just the self-supervised learning. You don't need to worry about the label. Yeah, you know the MIE, so you can just do it all the way. So, but they need a lot of computational source. Yeah, I think it's done by the Facebook, right? It's the Facebook. A very smart guy working the Facebook did this one. So yeah, so this one you can see. Yeah, we do the strategy for. Well, say yeah, it's not that really surprising. We have the best strategy. We can alternate that one, so that's the best one we can get. And the outcome almost, yeah, you can see about not very significant, but really we can see the performance is a little bit better. So yeah, sometimes it's getting the likely 10% on this data set. And somehow another data set is also, this one not that very significant, but still like 2%. It's depending on the different database. So this one it is something like the 7. So the very stable things or stable finding or consistent finding is the strategy alternate. That's one is definitely be the good strategy. So we can confirm. Yeah, so that's one. Yeah, come on, I want to finish it. So that. Yeah, that's the indicate the whole spatial continuity. So that's one is the immersed is result indicated the fusion the method the significantly improve the model performance, but the stage one is only temporal continuity, but the lack of spatial continuity. Second one is similar reason because we add together it's already distract or disrupt the continuity. That's another. So if we can convert and inverse this one, then it's getting the better concentration of both spatial and temporal. And sometimes it's the spatial continuity is something disrupt, and then randomly it's also lack the both spatial and the temporal continuity. So that's one is the things. So again, we didn't train the model. Okay, the model we directly using the already tuned large. So this one you can know they already can automatic to extract already from us the pre-trained one. Okay, so that's one the things we have, and so this one basically, yeah, so this one is basically the conclusion we have. I already say so that's one is just say an exploration to handle multimodal data for dynamic emotion repetition. So we introduce a new novel framework for the multimodal data integration that we are supervised the learning models. And we also investigate the fusion modality, so helping us to get the better fusion modality. Okay, that's it. So any question? So we have seen a little bit late. So. It's a basically Fourier transform. It's very especially we use the FMCC is for the speech data. Yeah,
the temporal frequency.
Yeah, exactly. Yes.
What's the concatenate function? So you concatenate the.
Oh, we are not. We using the window. It's the window. It's actually the moving window.
Yeah.
The wood window is the length of the 1 second. So we're sliding this window according the time domain. So this sliding window, you can see this is the segments. The stepping segments are about 100 milliseconds. Okay. So that's why you can see we have a lot of overlap.
Yes.
Yeah. So that's with slide.
Understood.
Yeah.
Thank you.
Sure.
Data set when you on the object, did you have like the to prepare the data, or is it natural?
Oh, no, we didn't, we don't have the much data, so we use we test on standard data. Yeah, and the MAE, part of the MAE is they trained from YouTube data. So that's why you can see how they using just you can see they are using the time take out something and then just train. That's we don't have the direct data. We want to just give some data and produce the best fusion of the region. Okay, that's it. Okay, thank you.
Oh, sorry, we have another question. Just a short question. Could you tell when you have compared different methods, if it is exactly the same data set? Because you said that video is the worst one.
Video is no. Wait a moment. Wait. Yeah. Oh, yeah. This one. Huh? Hey, why? Huh? Oh, sorry. We need to share this one. Hey, huh? Why? Hey, update now? No. That one is.
We can,
What?
and then we can reopen from the folder.
Wait, no, this one.
Yeah.
Oh, okay. We are using this one.
Let me close, just see.
Sorry. Oh, we have some technical power.
See?
Yeah,
Yeah,
it's,
don't
the
know.
QC is correct. Oh, okay, then I will read it for you. So sorry. So yeah, it cannot be open that one. Oh, okay.
So you
It's
can
coming.
go-
Yeah, going down. Yeah. Yeah, there's here. Yeah, we test, you can see. Yeah, you can see video only is the this one. Yeah, it's a worse one. So actually the audio is better. So yeah, maybe a lot of tone. They are, because they are, especially they have some, imaging is camera is not fixed very well, because people is tone, actually we usually be doing that. Maybe this is the
You have
reset.
sample to 60.
Uh,
Everything is done sample to set 24 because it's too much.
Sorry?
But perhaps you have done sample a bit too much.
Uh,
You have done sample from 19 to 16, if I remember well.
In 1916, I don't know. So we use this one, you can see this one is general. Yeah, this one is maybe I don't know the data. I have no idea. So this is my student work. But this one, they are from the publication, you can check this publication. They are published this data. It's the percentage. We didn't use our own data for comparison because more standard, you provide the database. They also have a lot of paper using this data, at least on reference. Yeah.
Thank you.